Okay, so for this question, we have an object that is here on this plane, and it's moving up with a force, and there are different other forces acting on it, not just this force in this direction. Also a normal force up and the weight of it down. So here we can do a series of equations to try to figure out the acceleration that is needed to push this object in the direction of the force. So here we have the total forces in the y direction is equal to m times a in the y direction, which is also equal to n, or the normal force, minus the mass and the gravity, which is w in this case, cosine theta. So that's this. And then the equation for the sum of all the forces in the x direction is equal to mass by acceleration in the x direction, which is also equal to the normal force minus the mass times the gravity, which in this case is w, times sine theta minus f, minus the force, which is also equal to mass by acceleration in the y direction. Now we can simplify this to say that acceleration in the y direction is equal to w sine theta minus f over m, which is also equal to mass times g, or gravity, times sine theta over m. Now, with this final equation that's very simplified, we can go ahead and plug in our numbers. So we know that our mass is 2, we know that gravity is 10, and we know that sine theta is sine of 30, minus 15, which is the force, divided by 2, which is the mass. Now, if we simplify this in the calculator, we will see that our answer is 2.6 meters per second squared. And we say that it's negative because this is showing direction. This means that it's going in the negative direction, but it doesn't necessarily mean that the value is negative.